Previously on What is Probability? So last time we talked about biased methods, and these are methods of taking things from the population for our sample and studying that sample, only when we take that sample, there are issues. We talked about volunteer sampling, where we ask who wants problems, and then we get all the people who answer have problems. That's the problem with volunteer sampling. We then talked about convenience sampling and how there's a reason why they are convenient, and perhaps that has to do with their answers. So you have to be very careful about biased methods of sampling from the population, along with all of the other biases that could somehow wheedle your way into any survey or observational study or experiment that you might want. What is probability? Episode 6, Process. Illustrated and narrated by Isabel. So today we're going to be talking about unbiased methods, because there are perfectly correct ways to take a look at a population and to grab a sample that actually makes it a little bit better. One case is the stratified sample. The stratified sample takes the population and it separates them into groups. So we separate them into different age groups, or different genders, or different races, and then we make sure that every group is got a representative. Every single group in our sample has a representative from each of the strata that we have chopped our population into. So, we've got bubbles, we've got pentagons, and we've got stars. All of them have very different ideas, all of them have very different beliefs, all of them have very different chemicals. So what we do is we pick one of each, and they serve as our representatives of the population. That way, we've got a sample that is more generally clear on representing what the population wants and needs. This is what the US Senate is based off of. Now, instead of pulling things at random, the Senate is actually a voted seat, so you vote for the people to represent you. In a true stratified sample, we would be pulling random people. So 2 random New Yorkers, 2 random Floridians, 2 random Michiganders. And those 2 random people would be representative of the state as a whole. Then we have proportional sampling, and this is what the US House of Representatives is all about. You see, there's a problem with stratified sampling. If we take a look at my population, there's a whole lot of blue bubbles, and only 2 yellow stars. So the blue bubbles are going to be very, very angry if they have an even vote with the gold stars. The blue bubbles represent more people. So in a proportional sample, they take specific proportions. So there's going to be fewer gold stars and fewer red pentagons, and there are going to be more blue bubbles because there are more blue bubbles in the population as a whole. So that's what the US House of Representatives is all about. The goal here is to take a sample from the population, but so that it's representative of the population, so that it's not identical to the population, but it has the similarities of the population. Once again, in the US House of Representatives, it's a voted position instead of a true random sample, which is really what is necessary. You've also heard, perhaps, about the US Census. The US Census is a study that obtains data from every member of the population, or at least it tries to. That is why when the census comes around every 5 years, they have commercials, they have mail, they have ads, all of those trying to get people to sign up so that everybody in the population gets counted and everybody is part of our sample. That's not actually a sample, that's actually the population. Fortunately, in the US Census, they have neglected to include people like those who are homeless, those who are in the country illegally. There are multiple people who are not actually included in the census, but are included in the population of America. So things get a little bit sketchy. Then there's the simple random sample. In the simple random sample, everybody is assigned a number. So we have our population, we assign everybody a number, and then we randomly pick numbers. How do we randomly pick numbers? That's a work for a computer or a calculator. Technology must be the thing that actually selects a random sample. Otherwise, because we're human, humans somehow add biases. Just for being alive, we add a bias. We come with certain things that make us biased. So we have to make technology do that part for us. So if the population is really, really big, but we know everybody in the population, we can number everyone in the population and then select a small little group. This is like if we have a school. Some schools are very, very large, graduating over 200 kids every year. That's a big school. We don't want everyone at that big school to be part of a dress code debacle or debate. So what we do is we randomly select people from the school's internet list, and that is who gets to be put on the group. Now, once we have the sample, what do we do with the sample? We've talked about how not to take a sample, now we've talked about how to definitely take a sample. Once we have a good sample, what do we do with it? Well, we have two options. We can either do an experiment on it or an observational study on it. In an experiment, what happens is we take a sample and then we choose who gets to be in the treatment group, who gets to be in the control group. So we randomly put people in the treatment group and randomly put people in the control group. This works for medications, fitness regimens, food, movies, that kind of stuff. So I can tell a big sample of people, okay, you have to take this green pill. And the rest of you have to take this blue pill. And then we get to see who dies faster. That would be an experiment because I am choosing who takes which pill. Or at least the computer is. In an observational study, the people in our sample come with certain things. So they already are in a treatment group or control group. We just have to look and watch and see what happens. We cannot attempt to influence any of the responses or the results. This would be something like smoking, cancer, mental disabilities, height, gender. Those things, they come with it. The people come with those specific issues or things or identifying markers. We can't force people to smoke. I can't gather a sample and say, okay, you guys gotta go smoke this stuff. You guys, you aren't allowed to smoke at all. Smoking, it's not, I guess, morally okay to force people to smoke. So all we can do is sit and wait and see if smokers die before non-smokers. That's what an observational study is. We need to sit, we need to wait, and we need to watch, which is the biggest problem with the new vaping craze. A lot of people like vaping, and we don't know what happens because we can't experiment with it. It's illegal to experiment and force people to vape if they don't want to vape. So we just have to sit and wait and observe and see who dies. It's an exciting time. Okay, so let's take a bigger look at what an experiment does. So we've got a population. First thing we need to do is actually select the population. As I was talking about previously, if we want to talk about ovarian cancer, the population better have ovaries. We need to delete some people. In this case, I want to delete everyone but the blue bubbles. The blue bubbles, that's where the issue is. I think that's the population that I really want to talk about. So we select the population. I want to talk about the population of blue bubbles. In the real world, it would be talking about, I want the population of all of America. Or I want the population of just New York State. Or I want the population of just New York State without any of the New York City people. Because they are a little bit weird. We love them, but they're weird. Then what happens is we select a sample. So once we understand who the population is, we randomly select our sample. We've talked about how to select a sample. It's not as easy as you think it is. Then we split the sample. Once again, we're going to use a random number generator, and we're going to split the sample into treatment and control. So 2 of the bubbles get to be treatment, and 2 of the bubbles get to be control. Then we start conducting the study, and I flood the treatment group with a nice green gas. Well, if I flood the treatment group with a nice green gas, the control group is automatically going to be different, because the bubbles see the green gas and automatically think they should react. This is where a placebo comes into play. So I'm going to flood both the treatment and the control with green gas, but the treatment has a very specific medication in it, and we're going to see what this medication does to the blue bubbles. For the control, it looks the same. It looks like the same green gas, but it doesn't have the medication in it. So we can see what happens if you don't have the medication in the green gas. And then we wait and see what happens. And look at that, something happened. So we can collect data. When we collect the data, we look at the treatment and say 100% of those bubbles became bigger and definitely greener. In the control, half of the bubbles didn't change at all, but half of the bubbles got bigger. This will then impact our conclusions. In our conclusions, we can see that the treatment definitely turns the sample green. That is a given, because in the treatment, bubbles are green, in the control, bubbles are not green. It might also make them bigger. It's possible that just time will make them bigger, and that poor little baby blue bubble in the control will get bigger eventually. Or it could be that the gas and the medication in the gas that we gave for the treatment group actually makes them grow bigger faster. It's a possibility. So more experiments would then need to be done. Let's talk about observational studies. In observational studies, once again, we select the population. Anyone who's not in the population, we get rid of. We don't care about them. Then we select our sample randomly, of course, because we don't want to do this on the whole population, because normally the whole population is huge. So we take a random sample. The sample is already split, so these bubbles either already vape or they don't vape. We can't force them to vape, so they're either vaping or they're not vaping. And then we get to see what happens to them. So we observe, and we observe, and we figure out that the treatment just became purple, and they got bigger. That's the collecting data again. So in the treatment, we found 100% became bigger and purple. And in the control, 50% have no change and 50% became bigger. Now, because we're just observing this, our conclusions are different. You have to be very careful. In an observational study, you can't prove that the treatment causes anything. In this conclusion, the issue might make the bubbles purple and might make them bigger. But we don't know that for a fact. It could be that those bubbles all get their vapes from the same vape shop, and that vape shop has asbestos in it. Well, if that vape shop has asbestos in it, they're going to have lung troubles, regardless of if they actually bought the vape and did something with the vape or not. So because all we can do is observe, because they put themselves in the treatment or the control, we can't 100% say that this causes this, that vaping causes people to die. We're pretty sure it does, and it's pretty obvious based on the treatment and the control what happens. However, we can't say that with 100% certainty. So if we can't say that with 100% certainty, why would we even bother? Why would we even bother taking a sample and running an experiment or running an observational study? Why is this important? Well, that's what we are going to be covering in our next episode.